Welcome to Ask and Learn.
So we are being asked to use the mean value theorem to prove the inequality, the absolute value of sine of A minus sine of B is less than or equal to absolute value of A minus B for all A and B. So since f of x, we can let f of x equal sine of x. And we know that the derivative of f of x is cosine x. And we can actually, since sine and cosine x are are continuous and differentiable, we can actually apply the mean value theorem right away. So we can write that there's some c in f prime of x, which is cosine x, cosine of c. There exists a c, it's just that the average slope is equal to the function, which is sine of b minus sine of a over b minus a. So we also know that the cosine, this statement right here, so this statement right here, cosine is actually negative. It's bounded between -1 and +1. And this statement can actually be rewritten in terms of absolute value sign, because the absolute value symbol actually represents distance. You can think of absolute values as distance. And so this statement right here are the same. So we're actually going to rewrite this statement here. And since we applied the absolute value function to this side, we apply it to the right side as well. So we have to rewrite this as absolute value of cosine of c is equal to the absolute value of sine of b minus sine of a all over b minus a. And now we're going to go to the next page. Recall that the absolute value of cosine c is less than or equal to 1, so we're actually going to substitute that 1 into our equation. So we're going to write sine of a minus, sine of b minus sine of a all over b minus a is less than or equal to 1. And then we're going to multiply b minus a on both sides. So we're going to get sine of a, sine of b, apologize for that, minus the sine of a, and this is also still an absolute value. And then the b minus a is also an absolute value. So bam, bam. And then we can rewrite this as sine of a minus the sine of b to a minus b. And that is our proof. We have now proven our statement.